Welcome to Lesson 9C, T's in ventilation ducts. This is probably the shortest of our video lectures. However, it's also very important. So don't let the shortness fool you. This is a very important module because you need to do this in order to set up flows with recirculation. But what is a T? It's when two HVAC ducts, in this case, two pipes or ducts, join together into one. I'll make a quick, simple sketch here. Suppose you have two ducts, 1 and 2. The flow is coming in from 1 and into 2. And then this is the T, TEE, which then combines into the outlet duct 3. 1 and 2 combine into 3 at this T in this case. We're dealing with ducts that have contaminants, so the bulk flow is Q1 with some contaminant concentration C1. This one's Q2 and C2. And this is Q3 and C3, which are the unknowns in this case. We're dropping the J subscripts. These are the mass concentrations of some species of contaminant. We're assuming vapors here. A similar thing works with particles. So how do we analyze this? It's quite simple. We can do the bulk flow first. And this is simple fluid mechanics. Assuming incompressible flow, Q1 plus Q2 has to equal Q3. The two flows combine into one. And then for the species, this is species mass flow. Remember, we're dropping the J subscript, but the mass flow coming in, m dot mass flow rate, m dot 3 would be m dot 1 plus m dot 2. And we write that, as we learned the first week of class, C3 Q3 equal C1 Q1 plus C2 Q2. And if we solve for C3, if that's the unknown, C3 is equal to C1 Q1 plus C2 Q2 over Q3, and that's our solution. And as I said, this is critical to ventilation systems with recirculation. When you have recirculation, you're going to be taking air out of the room and combining it with air coming from outside, and that will require a T like this. So let's do a simple example. Bulk air, which contains some vapor contaminant, flows from two ducts 1 and 2, combined to one duct 3, exactly as I sketched above. And we know Q1 and C1, Q2 and C2. We need to calculate Q3 and C3. So let's use the equations that I just derived. The bulk air, Q3 is just Q1 plus Q2, is equal to 1.0 plus 2.0. Those are both in units of meter cubed per minute. So this gives me 3.0. I'll give all my answers to 3 significant digits. Meter cubed per minute equal Q3. And then for the contaminant mass, we had the equation C3 is C1 Q1 plus C2 Q2 over Q3, and just plug in the numbers. You can see that these meter cubes per minute cancel on top and bottom, and I used Q3 from here. And when you plug everything in, you get 11.666, etc., milligram per meter cubed. So to 3 digits, C3 is 11.7 milligram per meter cubed. Let's do a quick sanity check.
Sir, I'm not familiar with this phrase. What is a sanity check?
It just means to check if your result makes sense, Sean.
Thank you, sir.
We see that C1 is less than C3 is less than C2. Ducts 1 and 2 are combining into 3, so we would think that C3 must be something in between C1 and C2. So for a sanity check, let's see if that's the case. We had C1 was 10, C3 is 11.7, and C2 is 15. So that makes us happy because it agrees with our sanity check.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos.